today's problem of the day at LeetCode. Find the maximum length of valid subsequence 2. So yesterday it was part 1, and what is the difference between these two parts I will discuss later. First of all, let's read the problem statement. So you are given an integer array nums and a positive integer k. A subsequent sum of nums with length x is called valid if it satisfies this condition. It is the same condition as it was in part 1, but in that part this k is exactly mentioned as equals to 2. So the part 1 it is always be equals to 2, but here it can be from 1 to 1000, right? And then return the longest valid subsequence of nums. So in the part 1 and part 2 everything is same, just the value of k is now has greater range, that is one from 1 to 1000. Okay, so in the previous part their greedy approach works. Because what why I'm saying this, you can watch my video on part 1. There I discussed, because of their the constraints were quite high, that is nums length was 10 to the power 5. So there are often square types of complexity which I will be implementing in this problem, because it is possible in this problem. As we can see, 10 to the power 3 length is, but in the part 1 it was 10 to the power 5. So greedy solution is required there. So that problem just have k equals to 2. So their possibilities of the reminder or modulo was just 0 or 1. And since it was modulo with 2, so we can easily uh, we we could easily solve that problem with comparing just the only odds or only evens. You can watch that video. So let's discuss for this problem how I can solve this one. Okay, so we should start from the part 1 itself. Then we can understand what is the exact difference in the implementation of the implementation and solution of the problems. So let's start with the part 1. So let's have some space for us. Okay, so in the previous part, k is exactly 2 always. So taking modulo with k or 2 gives us 0 or 1, right? And for 0, I need to manage that. I can include only those elements which are which having some or sum of two consecutive elements in the subsequence is even. So for that, there was two possibility that two numbers are even, even, or odd, right? And for having modulo equals to 1, I have to take even or even sequence, right? But as we can see here, that k is from 1 to 1000. So there would be possibilities that taking modulo with k, it would give us 0, 1, 2. It can be from 0 to k minus 1, right? And there are so many possibilities. And now it can't be solved using greedy. Why? Because previously it was just following a pattern, even, even, odd, odd, even, odd, even. But this time we have multiple results for the modulo. So if you visualize some test cases, you would find we can't apply greedy solution here. So let me write 1, 3, 2, 3, 1, 4, right? And one more case 3, 1, 2, 3, 1, 4. If we include 1, right? Let's include this, then and value of k is 3 right here. So both of the for both of the test cases. So if the let's check for the equals to 3. So if I take these two values, then 1 plus 3 would have modulo equals to 1, right? Okay, so let's take this one. And I'm checking since k equals to 3, so possible modulo can be 0, 1 or 2, right? So let's check for first 0. So if I'm taking 1 and 3, then it have the modulo equals to 1. So this would not be valid together. So let's include 1 and exclude 3. So in that case, I will include 1. Then let's check for index number 2 and its value is 2. So 1 plus 2 would be 3 and its modulo with 3 will give 0. So it satisfied the condition, so I will include 3. Sorry, 2. Okay, let's move to index number 3. Then it would have modulo equals to 2, which is not be satisfied If I take 1, then 2 plus 1 would be giving us 0 modulo. So I will include 1 also. And similarly, 4 will not be able to make into this subsequence. So now I have a subsequence with size 3. Okay, let's try out for 1. Let's try out for this case for 0 itself. Let's try out for 3. 3 plus 3 would give us the modulo 0. So I will include 3. And 1 cannot be included as 3 plus 1 would be 4 and modulo 3 would be 1. So now I can't take any more element into this subsequence. Now if I include exclude 3, so I will take 1 and so, as the previous case was, so I will have 1 2 1 as our valid subsequence. Now you can see that this subsequence is of greater size and this one has the smaller size. So taking an element or excluding an element decides the size of the answer. So uh, it means I have different possibilities at every index, that should I take or should I not take. So it means it is a kind of dynamic programming problem, cannot be solved with greedy. Okay, now let's analyze the pattern which I can follow in this problem. As the condition suggests that every two elements addition and after that taking modulo with k should give exactly same value as other window will have. So it means I have to check the previous element, right? If I go for any of the index, I will check the previous index I have included into the subsequence. So okay, if you remind a pattern from this hint, the previous index, right, or element basically, you can remind that okay, LIS also follow the same trend that it checks for the previous index to compare if the current element should be included into the subsequence or not, right? But LIS has a condition that the current element should be greater than the previous one. And here the condition is addition of previous element and the current element taking modulo with k should give us the same value always throughout the subsequence. So it is following LIS pattern, but condition is changed. Let's analyze the solution. So just taking the size of the array and initialize the answer with equals to 0. Okay, initially I have 0 length as my answer. Okay, so the which I was discussing that lies with changes condition. So condition is changed, and for each difference condition I have to store 1D DP array. What exactly means? If you know the LIS, what it is, it exactly to solve the LIS problem, we have to make a DP array which stores the maximum length of increasing subsequence to index I, right? And we have to do the similar task here. If I am checking for let's say modulo 0, then my condition becomes if modulo is equals to 0, right? The previous element and the current element. Modulo is equals to 0, then I will store the element, update basically the DP array with sorry, yeah. So DP I and 1 plus DP previous index, right? That is J, right? So I will if I'm including the previous element basically coming from the previous to this current element, then I will add one more with the previous length, right? Okay, so in this way I can easily store for modulo 0 that if I'm having modulo, let's find a modulo that is previous element and the current element modulo k, then okay, so if modulo is 0, then I will include the dpi equals to max of dpi and 1 plus dpj. Yeah, and if I'm checking for modulo 1, then I will check that if modulo is exactly equals to 1, then I will store into some other dp array that I equals to max of dp2i and 1 plus dp2j. The same thing I'm doing as we do in the LIS. The little change here is that I'm exactly changes the condition and now I'm checking for the modulus value. So for 0, I will be storing the lengths, the maximum length up to index I in dp array, and for modulo 1, I will be storing the maximum length up to index I in the DP2 array. Right? I have to make two different arrays, DP arrays, to store for different modulus value. So it now gives us a clear intuition that since I'm having k, which can be equals to less than or equals to 1000, so it will have multiple modulus like 0, 1, 2, 3, 4, and I can't make different k arrays. So better I should make a vector of vector, right? So for that vector, if I'm solving the part 1, then k would be equals to 2, right? And that time I will make dp of size 2, and uh, for each row I will have columns which would be the exact dp values like in the lisp tool, right? So it would be of size n. So in this way I will make mapping of modulus with the dp array which is storing the maximum length up to index I, which following the trend that every window of size 2, picking addition and then picking modulus with 2. Yeah, so dp2n. And since k it can be as large as can be good up to 1000, then it would have multiple values, so I can't resist up to 2 only, so I would make 2 to n, right? So now for this problem, this part, I have to make 2D matrix where I have to make k rows, right? In k rows for k different modulus results, right? Okay, so let's come to the code. So I have done the same thing. I made a dp vector of size k into n and travels from 1 to n. And if I'm at index, let's say 2, then the potential previous index can be 0 or 1, right? So I will iterate over the previous indexes from 0 to I, and just I'm taking a modulus, and whatever the modulus value, like if it's 0, then I would directly store into the 0th row, and if its modulus value is 1, then I will directly store into the first row. So it would manage internally itself. I don't require to give specific conditions if the modulus equals to 0, or if modulus equals to 1. I don't require that. So I can simply return the answer, and answer, as you know in the lie, is that the DP vector, any of the DP vector can be the answer. It's not necessary that the first index or the last index is storing the maximum answer or maximum length. So yeah, it is the complete intuition and the approach to solve this beautiful problem. For the dynamic programming, you have to think a lot of things. Uh, if you feel the beauty of this problem, that I'm iterating over the current index and the previous indexes, right? But storing the uh, values with the row as modulus and column as the index. I'm iterating over different things and storing at different things. This is the beauty of this problem, and making this problem a little bit complex and tough also. But I hope this is clear to you. Thanks.